So welcome everyone. Thanks again for taking the time to log in. This is Phoenix LiDAR and our very second webinar. The January webinar was a great success. So we're really excited about all the feedback we got. Our main reason for doing this, hopefully every month, is first to benefit, to keep adding value to the Phoenix clients around the world. So thank you all for being a great global community. And so we're going to keep trying to bring this to you every month. And secondly, we want to make sure that the world, all these surveyors and everyone, that we learn more about LiDAR and all of its applications. So to that end, if you would, please keep sending us feedback. Let us know what works, what doesn't work, some great topics that you'd like us to cover. You can always email marketing@phoenixlidar.com, and I read every one of those emails, so just let us know your thoughts. It's been an exciting month for us. We spent some time at ILMF, the International LiDAR Mapping Forum in Denver. Our partners at Velodyne did this great press release where they talked about how we were the first in UAV LiDAR at a commercial level, non-government, non-military. That was back in 2012 when we worked with them. And then LiDAR Magazine did a great feature on Phoenix LiDAR in general. So both of those articles are available on our website. Just go to phoenixlidar.com/news. -events, but just go to our website and click news. Okay, so today's topics is going to be flight planner and then LiDAR, UAV LiDAR tips and tricks. So without further ado, actually before that, we're going to have Sam, our chief pilot here, who has 25 years of drone flying experience, and he's going to be leading this webinar. We also have Eric McNeil, our post-processing engineer, one of them. He'll be answering questions in that chat box you see at the bottom of your screen. Eric Agnello is our sales director, and he'll also be available to answer questions. David Song, our regional sales manager, and then myself, Vu, the director of marketing. So now, without further ado, I'd like to pass it over to Sam Girardi, our chief pilot. Take it away, Sam.
Hey everyone, thanks for the introduction, Vu. It's that time again, Phoenix LiDAR webinar. We are coming to you live from our headquarters in Los Angeles. I'm very excited to be here. Today, our primary focus is going to be flight planning and best practices in the field. Basically, how to get good data. That's really the entire purpose of what we're doing here with LiDAR. So we're going to take a look at a few example flights. We're going to go through actually making the flight plan, everything from LiDAR parameters to camera parameters and any other sensors that we might have attached to the aircraft. So, Vu, if we could go ahead and switch over to the field notebook. I have some trajectories that we can kind of start to review.
You'll need to start the screen share.
My bad. Stand by one moment. How's that? Are we?
Yes, I see you now.
Okay.
Okay, we switched over to the field notebook.
Let's see. Stand by. Okay, my apologies there. A little technical difficulty. So here we have just an example of a flight plan. We're looking at these trajectories in Google Earth Pro. This is a very simple mission flown at 45 meters AGL. The green trajectory that you see is what we generated in the Phoenix Flight Planner. So we're going to go in there in just a minute and actually create a few flights just like this. The yellow trajectory you see is actually the path of the UAV. So you can see it's pretty close. There's a small discrepancy in the height. It looks like we flew just a few meters below our intended altitude, but overall quite good. You can see there are some unique features in this terrain where it kind of dips down into a valley right here, and you can see that the aircraft followed that trajectory quite well. So usually when we're planning a LiDAR mission, we'll start with looking at the area of interest, which is usually delivered in a KMZ or a KML format. So we'll review that on Google Earth, and usually I'll just start taking some measurements. So let's just pretend that the side of the hill is our area of interest. I will just take these away just for a second, and what I would do is I would take some measurements. So I would see that, you know, the length of this hill is maybe around 300 meters. If we're just scanning this side of it, you know, we have about 115 meter face. So that tells me right away that, you know, this is easily achievable in one flight, at least with most systems and most UAVs. Really, the best way to figure out how long this is going to take to fly is to actually start putting down flight lines. So for that, we would actually hop over to the Phoenix flight planner. So let me just log in here so I can get that up and running. The flight planner, I believe, is actually going to be free for everyone to try out for the next day. So as soon as you're done watching this webinar, you can start planning some of your own flights, and I'll show you how to import these trajectories into your autopilot software so you could fly them quite easily with almost any DJI drone. So let's launch the flight planner. The flight planner is somewhat processor intensive, so you do want to make sure you have a decent computer, decent. Okay, all right. You still have me? All right. So this is the Phoenix flight planner. Let's go to an area that I'm a little bit more familiar with. So jump back over to Los Angeles. And let's go to Malibu. Why not? We know that we've got a coastline here, which is pretty much zero elevation. And we know that this is actually a hill going up to the east, to the northeast. So the flight planner is very intuitive. It's very easy to use. Today, I'm actually just going to focus on LiDAR for right now. So I'm going to unselect photogrammetry. And we will be doing terrain following. Now with terrain following, we can choose our line segment spacing. Depending on the size of the area and the complexity of the terrain, I usually like to put it somewhere between 50 to 80 meters. Here, we'll do 50. This is going to determine exactly how many waypoints we have on each flight line. It's also how often the aircraft will be changing altitude. Okay, so 50 meters is good for this test. Flight parameters with a system like the Phoenix Scout, we would fly usually at a maximum of 45 meters to ensure that we get good data. Depending on what we're scanning, if we're scanning dense vegetation, you should consider that you have approximately a 60% usable field of view. If we're scanning a relatively flat area, if you're just scanning a field, if there are not many vertical objects that you need to capture, then you can have up to a 100 or maybe 110 degrees of usable field of view. For this purpose of testing, we'll set it to 90. So the 45 meter altitude, a very general rule of thumb is to actually match your flight line spacing with your altitude, your AGL. That will ensure that you have at least 50% overlap in the LiDAR data. The very minimum for processing flight lines is going to be 20 to 30% overlap, but really the more overlap, the better. If you are flying with 50% overlap, you're essentially scanning everything twice. You fly one flight line down, and on the way back, you're rescanning half of that area again. So let's go ahead and create a polygon. To do that, we just click. We'll create one point here, 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 and here. Now this is actually a little bit of a big area. Let's review our flight parameters. Generally, we will fly between 8 to 10 meters per second, sometimes a little bit slower if the conditions are bad. So we'll say 8 meters per second. All of these parameters we will go over in the actual Liche app. So we're kind of setting a baseline right now. And then, of course, before we fly the actual mission, we'll go over all the waypoints, all of the altitudes, all of the speeds. We'll make sure that we have nice rounded corners. We want the aircraft to fly like an airplane, like a fixed-wing aircraft, always flying nose forward. Never flying backwards or sideways, none of that. Let's go ahead and calculate this flight plan. You can see we have some flight lines. Now we need to decide what direction we're going to fly this mission in. There are a lot of things to take into consideration. So we have the terrain and weather that are the two main things. So let's actually start with wind. So generally in this area, we have an onshore breeze. So if we wanted to fly, parallel to the wind, flying into the wind and then flying downwind, we would adjust until we achieve, oh, I'm sorry, hang on just a moment. We want to adjust the flight direction. We've already set our flight line spacing. So flight direction, that's pretty close. If it's not that steep of terrain, I generally do like to fly up the terrain and then down the terrain. The reason for this is that generally it is easier to match the flight lines later and make the data as good as possible. If the wind is coming onshore and it's a heavy breeze, it's a consistent 10 plus mile an hour wind, then I would actually consider flying this whole mission rotated 90 degrees. So we can change the flight lines to be parallel with our hill. And now we are gaining and losing altitude in the turns as opposed to on the flight lines. So there really are a lot of ways to do this. We could talk about it for hours, but really the best way is to get out there and fly. What we do with missions like this is always fly them with a smaller drone. So typically a Mavic Pro or a Phantom 4 could work. But basically you're just flying the entire mission with a smaller, less expensive drone to make sure that there are no trees, there are no power lines, there's nothing that you would need to be concerned about. That way when you fly your LiDAR system, it kind of puts you at ease. You know that you've already flown this path and that it is indeed a safe path to fly. So yeah, this looks pretty good. If there was a heavy onshore breeze, I would be happy with this flight plan. One of the reasons why we don't fly into the wind and downwind is because not only is it very difficult for the aircraft flying directly into the wind, it's using a lot of power, it's also going to have a very high pitch angle as it's flying into the wind. When you're flying downwind, that pitch angle is going to be considerably less. In some cases, the aircraft may actually be flying backwards as far as the actual airspeed. The ground speed will be positive, it will match your parameter, but in some cases the aircraft may just be hovering on that downwind leg. So in order to have a more consistent data, flight line to flight line, it's just one thing to take into consideration. So let's go ahead and actually look at a flight with LiDAR data and terrain following. So for that, I'm going to launch Spatial Explorer. Spatial Explorer is part of the Phoenix software suite, primarily used for controlling your sensors in the field, also for monitoring real-time telemetry of the navigation system and the CPU. For right now, we're just going to work offline and review a flight, which I love doing because it really lets you study how the aircraft flew, and you can learn from that. So we're going to open, this is a terrain following test that we did a few weeks ago. There are no camera images, so I will just cancel there. And here we can see our trajectory. How does that look, Boo? Is that relatively clear? Okay. So for those of you that have our systems or that have flown LiDAR, you may know that the first thing we do is fly figure eights. We do figure eights at the beginning of the flight and the end of the flight, and the purpose of that is to help process the trajectory. These two flight lines, these two long flight lines that you see are the terrain following. So that's where we want to skip to. So I'm actually just going to go right to where that LiDAR data starts, which I believe is here, and hit play. Oh, I need to check one thing. Double checking the vehicle body rotation, looks good. Okay, so we have points on the ground. Great. I think we are looking at half of the data right now. I think we're looking at 16 of 32 lasers. And you can see the terrain, the aircraft is flying quite smooth. There's a very little bit of pitching and rocking about, but that can be expected. You know, this was a relatively windy day, but overall, pretty good. We were actually flying over some power lines, which you can see here on the hill. We captured those quite well. But most importantly, what we're looking at here is that the aircraft is doing a very good job of maintaining its distance to the ground, which is exactly what we want to see. That's the whole point of this. I'm going to select my point cloud and try coloring this by color by time and see if that visualization looks better. So now we're coming down the hill. Again, the aircraft looks good. Nice smooth descent. You can see it's moving a bit, but overall I'm quite happy with that. Has anyone had any questions that we want to touch base on? No? Okay, we're doing pretty good. So good. Okay.
And ladies and gentlemen, as we continue, just wanted to remind you at the bottom of your screen is a chat box, and you're most welcome to click that and then ask any questions you'd like. Our engineers and some of our sales team are available in case you have any specific questions. Thanks.
Okay, so we talked a little bit about wind. We talked a little bit about terrain, but let's continue with terrain. So going back to the Phoenix Flight Planner, there's a few things that I want to go over. Let's actually jump to the area where we were currently flying. Okay, so this is the hill that we scanned. The power lines are on the right side over here. Okay, so with altitude following, there is something that we really need to keep in mind, and that is what is the difference in elevation from our takeoff location, our home point, in relation to where our first waypoint is. So in this example, our takeoff location was right kind of in front of this white container, and our first waypoint was roughly just over the bend in this road. So what we had to do was measure the elevation difference from our home location or our takeoff point to the area where approximately our first waypoint is going to be over. In this case, I measured it in Google Earth. Actually, let's go ahead and do that again. So here we will just draw a path from approximately the takeoff location to where the first waypoint is. And I will save that. Let's look at the elevation profile. So it looks like 1293 to 1335. So we would need to convert that difference to meters, and then we would need to add that to our target altitude. So if we wanted to fly this mission at 45 meters, and I know that this point is 11 meters higher than our takeoff point, I need to set the first waypoint to be 56 meters and plan the rest of the flight plan accordingly. I think in the future we will add a simple offset feature so that we can do this without having to do the calculation, but for right now this is an effective and an accurate method to accomplish this. So yeah, that's the very basics of flight planning. I think that one of the next things that I want to go over are best practices in the field. It's really a whole topic on its own, but I guess the very first thing that I would want to mention is lithium battery safety. A lot of us are familiar with lithium batteries. To some of us, they are very new, but basically proper storage, proper handling, proper charging, proper discharging, it really does require special attention. So, one of the worst mistakes to make in aerial data acquisition is to not have properly maintained batteries. That can cause total loss in the event that something goes wrong. So a standard lithium battery, we know that they're fully charged at 4.2 volts per cell. We like to store them at 3.7 to 3.8 volts per cell. And of course, we don't leave them charged on the shelf, and we don't leave them fully discharged. We leave them at that happy medium. We don't want to drop them. We don't want to poke them. We don't want to leave them in the sun. That's one of the other big things I've noticed. When you go out to the field, most of the time, we have lots of Pelican cases with all of our gear, and usually they're black, and usually they get left in the sun, and the gear will get hot extremely quickly. So I always try to avoid that. Keep everything in the shade. Yeah. Boo, Eric, do you guys have anything to add?
At the moment, we have a question from Sue Freeman. She was asking about SRTM. So Sue, the flight planner is actually based off of Google Earth, so it's designed to be very simple. Most people seem to be pretty familiar with the functionality of Google Earth, so that's what it's based upon. We have a couple other people that were asking questions about will the offset apply automatically to all other waypoints?
Yes. So once you adjust that first waypoint, the rest of the mission is going to be based around that reference point. So if you're flying in a flat area, this isn't an issue, right? If you take off, you fly to 45 meters, and if you fly to your first waypoint and you're still 45 meters from your home location, then it will work fine. But in many cases, we're starting our missions, maybe 500 meters away, and so we need to know what that elevation is at that point on the ground, directly under the first waypoint. I'm going to go ahead and actually make a quick flight, and we will import it into Liche, and that's really the final step here. So stand by for just one moment.
And Sam, can that be imported into a PixHawk mission planner as well?
As long as PixHawk supports KML trajectory, then yes. I'm not sure if PixHawk imports the Z value, which is that's really why we've chosen to use Lychee, is because we can create a three-dimensional trajectory, and Lychee will actually reference those altitudes for us. Previously we were using an autopilot program by Hanger, formerly Auto Flight Logic, and that software worked very well, but one of the limitations was that we could not import that Z value. So that's where Lychee really comes in handy.
Okay, and for Ray, he was asking about LiDAR flight planning versus photogrammetry, and what I would say on that is LiDAR flight planning is typically more simplified with photogrammetry depending on what you're mapping. You may need to do additional flight lines crossing over or even circling around certain objects. So with LiDAR, typically you're just doing a basic lawnmower pattern, but insofar as that's concerned, then yes, it is very similar.
Yeah, one of the big things to take into consideration with flight planning, especially with terrain, are oblique angles. So if you have tall objects like power lines or tall trees or any large vertical object that you need in your scan, you're going to need to fly closer to that object, if not directly over it or right next to it. You're going to need a few extra flight lines, basically, because everything that we're calculating is overlap on the ground. As soon as you introduce a vertical object, it could potentially be in that the oblique angle where it's not going to be captured by any of the sensors. So this is a really simple trajectory I've set up here. It's just 5 flight lines. So once we have calculated our flight plan, we're happy with the parameters, we're happy with the direction, we will save just a KML file. So we have an option to save a KMZ file here, which would include some extra information, like if we wanted to project the LiDAR swath, or if we were taking photos, we could project where we would want the photos to be taken. But for importing into a flight controller, we want just a KML. So you can see this button on the right, download trajectory only. We'll go ahead and click that, and we can see that it's saved here. There is one more step before we get to the iPad, and that is the Lychee mission hub. So what that does is that allows us to take this trajectory and import it into the iPad. So this is the Lychee hub. You can get to it just through their website. So your screen is up. Stand by.
Sam, while you're pulling that up, I have a good question here from Cole Moon. He said, have you seen many discrepancies between the Google terrain data and what is actually on site?
That's a very good question. I want to get to that as soon as I get my screen working. Stand by. You still have my audio, right? Yes. Yes. All right. I don't see my share button. Stand by. Hey, Lou, maybe you might want to try to fix this for me. Beautiful. The screen share button.
Says screen share.
Okay. Actually, to be fair, it says share screen. So, all right. All right. So, I think I need to log into my account because this is not the machine that I normally operate from. So there we go.
That's probably the login button, Sam.
Thanks, Eric. So missions, we're going to import the KML that we just created. So missions, import, choose file, and I assume it's the most recent one. Open, and then import. So now you can see that trajectory that we just created in the Phoenix Flight Planner is in our mission hub now, and you can see the altitudes change. So from 45 meters down to 18, down to actually negative 7.4. So, to properly figure this out, I would go back to Google Earth, and we would take another quick measurement. And this is going to be real rough, but I think it's about there. And then again, I would look at the elevation profile, and yes, we can see that there's quite a bit of elevation difference. So it would be 45 meters plus the difference from our home point to our first waypoint. Generally, I won't make any changes to the flight plan through this interface. I will immediately save this flight plan so that it will show up in our iPad also. Okay. Now, just looking at this really quickly, I can already see there's a few things that I would want to change. Sometimes the line segment spacing falls right before a turn. So in that case, I would usually just delete that waypoint right before the turn, and then I would readjust this curve size to closer match the following turn. So on this menu, we can control the curve size. That looks pretty close. Let's just see what the other one is. So yeah, 13 meters, and we'll make this one 12. You could potentially fly turns that are not as rounded. It's still okay. You just don't want to stop and rotate or just do a rotation. You want to maintain some forward motion and have just a nice smooth looking turn. So waypoint 1, let's just go through these waypoints one by one. That's what I always do before a flight. So we check our altitude, 45 meters. We go through. So here you can see we have another waypoint that fell just before a turn from the line segment spacing. So again, I will just delete that one, and then we will increase the curve size. Let's continue. So waypoint 4 looks good. 5 is good. 6 is good. 7 is good. So here's another one, waypoint 9. We'll go ahead and delete that. Adjust our curve size. Looks good. Yeah, this that's pretty good. So I would save this again just because I did just make some changes, even though I said I wasn't going to. Let's see if we can switch over to the iPad.
And while Sam is connecting the iPad, if you'd like to give this a try, we made the flight planner open to the public for actually 2 days. So if you go to our website, phoenixlidar.com/flightplan, you'll be able to scroll to the very bottom. It's free to all Phoenix clients, of course, but that login is required. So if you don't have a login, we created a button there, and so you can just check out this tool. We're still building it out as we go, so please do send feedback, and you can send that to marketing@phoenixlidar.com. We're working on branding and all that kind of stuff, but this is an exciting time for us because we're spending all this time releasing great products like LiDAR Mill and Flight Planner, so we'll touch on that later. But Sam, how are we looking? Okay, passing you back to Sam.
And for Andrew, no, we would not be flying backwards. We're maintaining a forward trajectory always through those turns, so you're flying forward constantly.
Sure. Actually, let's go back to those questions real quick. Sorry, I got a bit distracted. So the first one, Eric, was regarding how accurate is the elevation model that we're basing these waypoints off of, right?
Correct.
I would say that in most areas, it's within 10 to 20 meters. So that's why we highly recommend, flying a smaller aircraft first to make sure that it's safe. I think, in most of the testing I've done, I think it's actually been a little bit better than 10 to 20 meters, probably within 5 to 10 meters. But again, every area is going to be different. And I guess, in some areas, the terrain does change. So, whenever that terrain model was created, it could be different now. So that's why we will always test fly. And was there one more?
Yeah, Andrew was asking about, he basically asked, aren't you flying backwards for half of that?
Negative. No, we fly like an airplane. So we fly, we bank, we turn, we make it look as pretty as possible, and it makes the data look quite good. The main purpose of flying like an airplane and always keeping that course heading, following the path, it mainly has to do with the way that the navigation system works. You're going to have more accurate data if you fly the way that we're recommending. Okay. All right, so let's look at Liche. This is a previous flight that we did testing. The visualization in this app makes it look like it's clamped to the ground, so it's not going to look quite as good as it did on the PC. But let's open the flight we just created. So there's those 4 buttons on the left side. The top one is open. Go through our flights and web test, load. So there we go. Now it's basically as simple as doing a final test of, a final check of all these parameters. Again, we're checking the speed. With Liche, in order to get that flight direction that we were just talking about, I click the 3rd button down on the left, and for heading, is it still buffering, or can you see that? There we go.
We're good.
All right. For heading, we choose auto, and auto will follow the course heading that we want it to. Here we also set our max speed and our cruising speed. I always set them to be the same. Typically with terrain following, we will fly around 20 kilometers per hour, which is roughly 6 meters per second. From here, we would just do a pre-flight check on the aircraft and connect this device to our aircraft transmitter, and we could upload the mission by pressing the 4th button on the bottom left, the play button. That actually uploads the waypoints to the flight controller in the aircraft. What that means is that this flight is not dependent on the link to the aircraft. So if you momentarily fly near some terrain where you lose connectivity with the transmitter, the aircraft will continue its flight path. So again, you want to make sure that these flight paths are safe and free and clear from any potential obstacles. Yeah, I think that's pretty much the basics of how to go from a KMZ polygon to a finished and polished flight plan. The next step is just to go out and fly.
Sam, is it not true that you sometimes fly inverted like Maverick from Top Gun?
Depending on the conditions, I'll do whatever's required. But I haven't pulled negative 6G in a dive yet, so we have yet to get there. But yeah, anyone that has any questions about flying, about UAVs, please feel free to reach out to me. Like Vu mentioned, I've been doing this since I was quite young. I take it very seriously, and any problems that you have, I want to find a solution for. So yeah, I look forward to hearing from you guys.
Thanks, Sam. Thanks, Sam. So if you'd like to get in touch, you can always email me. That's our marketing email is just marketing@phoenixlidar.com. It's actually quite easy to remember, but I can definitely help you communicate with Sam should that ever be needed. So while Eric is taking a look at the last few questions, I wanted to just remind you, if you'd like to check out the flight planner, it's phoenixlidar.com/flightplan. You can also look at some of the other stuff we have, like LiDAR Mill. Just go to our website and click software at the top. LiDAR Mill, the main idea there is to simplify and automate a lot of the post-processing for LiDAR in the cloud. So our goal is we keep building these different software platforms. We keep innovating this hardware, and the goal is to make LiDAR a lot easier for everyone to use. And the end goal with that is to help you to expand. We want you to be able to take on more projects, and we want to make it simpler for you to do so. So in any case, thanks again for taking the time to log in. I'd like to pass briefly, this over to Eric Agnello, our Director of Sales. But before that, don't forget, send us topics. These monthly webinars are for you. So email me at marketing@phoenixlidar.com. Let us know what we're doing well and what we can improve on and what you'd like to hear.
Hey guys, this is Eric. Just a quick little word from our sponsor, which is us. So I just wanted to let you guys know about a few new products that we're launching. We've recently expanded our Scout series. So we now will have the Scout 16, which is, for those of you familiar with our product line, the traditional Scout, I guess we'll call it. We're also now going to be doing the Scout with the HDL 32E, the 32 channel sensor from Velodyne, so there'll be a Scout 32. And then there's also going to be a Scout Ultra, which will feature the new Velodyne Ultra puck, which is a 32 channel puck with extended range and density. Some of you may also know we're also launching the Mini Ranger DL, which will be the basically the same Mini Ranger, but based on the VUX 1 DL sensor, which is downward looking, which essentially takes all the points from the Mini VUX and focuses them in a downward angle, providing a much higher density than the regular Mini VUX, which is great for a variety of applications. Pardon me. We're also going to be releasing a variety of new pipelines within LiDAR Mill in the coming months, so definitely keep an eye out for that as well. And if you have any questions on new products or any products for that matter, feel free, of course, to email us either at info@phoenixlidar.com, or you can even email me directly, Eric, E-R-I-C, @phoenixlidar.com. And as always, we're more than happy to answer any questions that you may have. And thank you guys so much for attending and all the great questions. And I think, Vu, are we going to hang on here for a few more minutes and take some questions? Or
Sure. So we can hang on for a few more minutes, take a few more questions. I'm going to, once we get the recording of this, we'll post it on YouTube and send out a link. Thank you all for registering. We'll also keep you in the loop for future webinars. So with that, thanks so much for coming. If you'd like to stay and ask questions, we'll stick around for a bit. Otherwise, we'll see you in a month.
hey, so we had a question from my buddy Tyler asking if we're going to do a webinar on LiDAR Mill soon, and the answer to that would be absolutely. Thank you for the suggestion that we already thought of, Tyler. And Corey, yes, I know you came in late, and thanks for joining us. Good to see you. We definitely are recording these webinars, and we'll be sending out links to everyone in attendance and pretty much anyone that wants it. So they're all recorded, and don't worry about missing any of the good stuff.